Hello everyone. So we basically have understood what a package is and what package manager is. Package manager lets you install additional set of packages which are not part of your Miniconda installation that you have done. So as we know, Miniconda comes with only a confined set of packages which you can use. But whichever packages are not in that scope, probably you might need to install them with the package manager like Conda. And the same is the case with Anaconda as well. So whatever Anaconda installation that you have done, it's not necessary criteria that all the packages that are existing out there are downloaded and installed. It's not the case. So you might need to use the package manager still in order to install additional set of packages that you might require for the project that you're working upon. So in this session, let's briefly discuss about all of these terminologies like scripts, modules, packages, and libraries so that we are not having any confusion moving forward. So first, I am trying to differentiate between a module and a script here. The left-hand side program would indicate a module. The right-hand side one indicates a script here. So all the definitions like function definitions or classes that you can define or any of the methods pertinent to those classes can be defined as part of the module, right? All of the definitions that you can be defined within a module. In script, you can not only define a specific function or a class, you can also invoke the function that you have defined, and whatever result that it returns can be stored in a specific variable, and you print out the variable so that the end user can read it, so that the end user can perceive what the result is. So you are executing the functionality that you already have written. So this is an additional piece of information that we can understand from the right hand side program, which is a script here. So in module, you will not be able to invoke these programs. You just have the definitions in place. So I believe you have pretty much understood the difference between a module and a script here. You not only define these functions or classes within a script, you also make use of them. You invoke those functions or methods specific to any of the classes, then get the result and you print out the result so that the user can read that or perceive the result information there. So you do the execution of all the definitions that you have done in the script, whereas you cannot do that in module. So all these set of modules, right? All these modules you might define as part of a package can be imported in a script. It's not necessary that I need to define this again, right? I need not redefine this when this same function is already existing in a different module, in a module called add. So I can, instead of rewriting the whole function, I can import that specific function called add from this module called add. The name of the module and the name of the function both are one and the same. In this specific case, it's not a necessary criteria that both of them should be same here. Okay. This statement is going to import this specific definition that I already have in module, right? So I need not redefine this in my script. So I can make use of this function that I have imported from add module and use that function, invoke that function by passing in the necessary values for the arguments and get the result back and do the necessary processing with the result. Maybe just print out the result so that the end user can perceive it. So this is how you can optimize the code that you can write or optimize the script that you can write by making use of the different modules that you must have written earlier. It's not again necessary that whatever module that you have written, only you should be using it, right? You might want to contribute whatever modules that you must have written to open source. Probably would want to publish this to something called Python package index. So we'll discuss about what Python package index later. But for now, let's again understand what a package is. So here, whatever modules that we have understood are nothing but .py files. So all of these .py files that are present within dateutil package are these modules. All of these modules are related to each other. So we can say that a package is a collection of related modules and sub-packages. I can rewrite this definition as a package is a collection of related modules and sub-packages. Now you understand that these are three different subdirectories that are present. So these are subdirectories that are present under this root directory of dateutil. I can call this dateutil as parent directory. So all the subdirectories are again called as subpackages. So dateutil is the package here. So a package here can be treated as collection of subpackages and collection of related modules here. So each subpackage, every individual subpackage here can again have a set of modules within itself. Now let's understand it by looking at the dateutil package that we have discussed just now in Python package index. So Python package index is a large repository where you can publish the modules that you have written or packages that you have written, or you can consume the packages that are written by your fellow developers, right? Either of that is fine. So you can either install the packages that are already available as part of Python package index, or you can also publish the new package that you must have written so that others can use it. So that's a collaboration there, isn't it? So it's not necessary that when you install Python, you'll get the whole repository of Python package index downloaded, right? It's not the case. So when you install Python, you only get few essential packages, which is a Python standard library. So all the libraries or packages, to be more specific, that are defined here within this document that I'm reading will be the one that gets installed along with your Python installation. With your regular Python installation, all of these packages or libraries get installed with you, right? There could be so many other packages that you might want to use, like dateutil, which is out of the scope of Python standard library. And that's when you need to make use of another package manager called as pip. So we have earlier learned about a specific package manager called Conda. So you can either use Conda or pip. So pip is another package manager which directly points to Python package index repository and finds the respective library or package that you are trying to install and install it to your environment. So that's the whole difference, or that's the whole idea of using pip. You can either use Conda or pip, it doesn't matter. Right? You can either use Conda package manager or pip package manager. Both should do just fine. So what exactly is dateutil here? So dateutil is a module that provides powerful extensions to the standard datetime module available in Python. So datetime is a module that's already available in Python, which could be part of the standard library that we have just spoke about. Right? So datetime, as we can understand, is a part of the standard library that has installed along with Python. There should be some extensions that we can provide to existing standard datetime module. So essentially dateutil is the one package that is going to provide some extensions to the existing datetime module. So in order to install all of these related modules or packages, or to be more specific, in order to install this additional package called dateutil, we might need to execute this command in the terminal. Pip install python-dateutil will let you install the dateutil package to your environment. Okay. In the next session, we are going to see how you can create an environment, how you can install necessary packages pointing to your environment. If you closely observe this specific code that's written within the same document here, so we understand that we are importing all the modules specific to this sub package called relative data. Now let me go back to the slides. I understand that relative data is not a sub package, it's a module, right? So there could be so many classes and functions that are defined within relative data. We are trying to import all of them. So from dateutil.relative data is a module. You are importing all the functions or classes that are defined within this module. Same is the case with Easter rule parser. Now we can scroll back to this particular slide and understand if Easter, rule, all of these modules are present or not. All of these modules are present. You can in fact go about importing a specific subpackage as well. Let's see if any of the subpackages is present, right? So parser is another subpackage that we have just now looked at. We are importing all the modules and in turn importing all the functions or classes that are defined within each and every individual module directly by using this particular statement. So this is how you necessarily import few specific modules of a package or the package as a whole, right? You can install package as a whole just by doing import datetime or dateutil, right? Import dateutil. Or you can also write from dateutil import star. So this is going to necessarily import all of the existing modules and subpackages from this dateutil package. So I believe we have pretty much understood on what Python package index is and how we can make use of package manager like pip or Conda in order to install additional packages which are not part of the Python standard library, which comes with the installation of Python. Okay. And we also have understood the difference between module and a script and also looked at what package is. Now let's look at what library is. As we have discussed earlier, package is a large collection of related modules as well as subpackages. So this is a formal definition of package that we have already discussed. What about module? Sorry, what about library? So library can be considered as collection of related packages and modules. So package here is the collection of modules and subpackages, but library can be treated as collection of packages itself, along with few specific modules. Most often, the developers or data scientists tend to use these terms interchangeably, and it's totally fine to use these terms interchangeably. So sometimes we call packages library and library as a package. That's totally fine. So, but remember this basic difference that package is a large collection of related modules and subpackages, whereas library is a collection of packages itself. Okay. So this is a basic difference between package and library. An example of library could be matplotlib. Matplotlib is data visualization library that we are going to deal with in one of our upcoming modules. But examples of package we already have dealt with. The dateutil is one such package which you might need to install externally using a package manager like pip. Okay, cool. So in the next session, we are going to look at what virtual environment is and how we are going to install these necessary packages that we are talking about into the specific virtual environment that you must have created. That's all in this particular session. Thanks for watching.